Hello and welcome, my dear students and my viewers, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you all to today's session. In the session today, we are going to be using LHospitals Rule for determining limits of indeterminate forms, and this video is going to be very useful for all my grade 11 and 12 students. Let me give you the learning objectives of today's session. In the session today, you will learn how to determine the limits of functions that result in indeterminate forms, and you will also solve some AP calculus questions on using LHospitals rule for determining limits of indeterminate forms. So let's get started. Let me give you the key concept for today, that is what is LHospitals rule and how and when we can apply this rule. So LHospitals rule first of all helps us to evaluate indeterminate limits. So what are these indeterminate limits? These are the limits which are of the form 0 by 0 or infinity by infinity. So whenever in a question on limits you are getting this form 0 by 0 or infinity by infinity, that means it is an indeterminate limit or the indeterminate form, and we need to go for LHospitals rule to find that limit. So this LHospitals rule helps us to find the limit x approaching to c ux over vx. So you will see two functions which are divided in this form, ux divided by vx, and when the limit is approaching to a particular point, x approaching to c, then the numerator and the denominator, these two limits will approach either 0 or both of them will approach towards plus or minus infinity. So whenever this kind of a condition is true, that is when you have the indeterminate limits, and then you are going to go for LHospitals rule to find the limit. So what does this rule say? Now let's understand, very important. The rule says that if this limit exists, so that means if the limit x approaching to c u prime x over v prime x, that means u prime x or the first derivative of ux divided by vx, if this limit where the x is approaching to the point c is existing, then the two limits are also equal. That means if you have to find the limit of this function x approaching to c ux over vx, which is coming out to be indeterminate, then you can simply differentiate the numerator and the denominator. So you get u prime of x divided by v prime of x, limit x approaching to c. So these two limits are going to be equal. So in order to find the limit of an indeterminate form, you will just apply the LHospitals rule and differentiate the numerator and denominator of these two terms. So that is essentially what is your LHospitals rule, and let's see now some examples on this rule. So this is the first example that we'll be taking, and in this one, let me just read out the function for you. So you are given 7x minus sin x divided by x square plus sin 3x. This is the function. Definitely you can see it is in the numerator divided by denominator form, and then the limit is approaching x going to 0. That means the point at which we are trying to find the limit is 0. So at this point, let's find this limit. And in order to find this limit, to check whether it is having an indeterminate form or not, we will do direct substitution. So we are substituting the value of the point which is given to us here, and the point is x equal to 0. So let's just replace x everywhere in this function with 0. So when we do that, 7 times 0 minus sine of 0 divided by 0 square plus sine of 0. So this will result in the form 0 by 0, because we know that sine of 0 is also 0. So this is giving us an indeterminate form. Now that we know it is an indeterminate form, we are going to be using the LHospitals rule, and let us just quickly see and remind ourselves of the LHospitals rule. So this rule says that this limit that you need to evaluate, limit x approaching to 0, this function is going to be equal to the limit same value x approaching to 0 of the derivative. So whether you take the derivative of the numerator and the denominator, just put that equal, and these two limits are going to be of the same value. So in order to find this limit, which is indeterminate right now, we will just do the derivative. So let's differentiate the numerator 7x and sin x. So this is what you will get when you apply the LHospitals rule, and for the denominator you will have, let me change color, d by dx of x square plus sine 3x. Now here you can simply use your rules of differentiation. When you differentiate 7x, you will be left with 7. When you differentiate the trigonometric function sin x, you will get cos x. And when you differentiate x square, it's just the power rule 2x, and when you differentiate sine 3x, chain rule 3 cos 3x. So this is what you get when you differentiate. Now we have to also look at the limit in order to evaluate. We'll go back to the point x equal to 0, and we will now try and do the substitution to solve. So in the next step, when you do the substitution, you are putting everywhere where there is x 0. So 7 minus cos 0 divided by 2 times 0 plus 3 times cos 0. This is what you get. Now remember, cos of 0 is 1. So you are going to use that value. Here this is 0 already. So simplify. 7 minus 1 is 6. You may just put this additional step. And then here this is already 0. So 3 is here. So 6 divided by 3, that is going to be 2. So we have got our answer using L'Hopital's rule for the limit. Because this limit is existing, so we were able to apply L'Hopital's rule. That's an important observation. Hope the last question was clear to you, and let's now do one question together. This is a multiple choice AP Calculus AB question. It has 4 options A, B, C, D, and we need to check which is the correct answer and answer the question. So here, first of all, the point which is given where the limit needs to be found is x equal to 0. So we are going to do direct substitution to check for indeterminate form. So it's going to be 0 in the numerator for sure, because 0 is multiplied to any number giving you 0. So here it is 0 plus 1 sine 0. Again, sine 0 is 0. So this is 0 by 0, which is my indeterminate form. So I'm going to be evaluating this indeterminate form or the indeterminate limit using L'Hopital's rule. So let's go for L'Hopital's rule. So we are going to write this limit is same as the derivative. So I'm going to do d by dx of the numerator and d by dx of the denominator. So let's write both the functions here. Okay, so we are going to differentiate this and this. So let's get to the next step where we are going to differentiate. So here there are 2 functions which are multiplied. So to differentiate the numerator, we will definitely use product rule. Similarly, in the denominator, if you see x plus 1 is multiplied to sin x, so this rule will help us for the denominator also. So let's differentiate one by one. The derivative of the first function x is 1. Cos x is as it is, and then x as it is, and derivative of cos x is negative sin x. So I've applied product rule for the numerator. Let me come to the denominator now. So if I differentiate x plus 1, the derivative is going to be 1, because the derivative of x is 1. 1 is a constant, so its derivative will be 0. So 1 is the derivative sin x as it is. Then you have to write x plus 1 as it is and the derivative of sin x. So derivative of sin x is very easy, cos x. So this is how you have differentiating. Now don't forget the limit here. The limit will be same, because by L'Hopital's rule, both these limits, the one which is asked and the one which you've got after differentiating, is going to be similar. So let's just simplify this a little bit more before we do the substitution. So this is going to be cos x minus x sin x in the numerator. In the denominator, you will have sin x plus 1 times cos x. Okay, so now we are going to do the substitution. So we will put x equal to 0 in this expression to get our final limit. So this is the limit which we wanted, and by L'Hopital's rule, these 2 limits are going to be equal. So this was going to be cos 0. Now this term I'm not writing. Why? Because 0 multiplied to anything is 0, and any which ways sin 0 is also 0. So this is gone. Numerator is just cos 0. Similarly, in the denominator, if you put x as 0, this is gone, sin 0. So this will be nothing, and you're just left with 0 plus 1 times cos 0. Now cos 0 is 1, so this is 1 over 1 itself. So the final answer is going to be 1, which is the B part. So the answer here is B. This is how you solve the multiple choice question on indeterminate form and L'Hopital's rule. So let's now solve a very important AP Calculus AB question. This is a multiple choice question, and I'm going to explain each step of the question, how we are going to arrive at the solution. So there is a function given to us, fx, which is this one. Then you are given another function g prime of x. This is the derivative which is given. You're not given the function g. However, you are also given one condition here, that the limit x approaching to infinity of gx is infinity. And what we need to find here, we need to find the limit of this function. Limit x approaching to infinity fx divided by gx. So let's try and find this limit. So this is going to be limit x approaching to infinity fx divided by limit x approaching to infinity g of x. Now you're already given that g x is the derivative is already given to you, and you're also given the condition that limit x approaching to infinity g of x is infinity. That clearly tells us that the denominator is infinity. Now let's look at the numerator. So when we are doing that, we can even substitute this function directly. So limit x approaching to infinity 2x plus 3 times e to the power negative 5x. Now if you try to substitute here x as infinity, you will see that this function also approaches to infinity. So this limit has come out to be infinity by infinity, which is your indeterminate form. So because it's indeterminate form, we can apply L'Hopital's rule. Now L'Hopital's rule says what? It says that this limit which you need to find is equal to the limit of the derivative. So limit x approaching to infinity f prime x over g prime of x. This is going to be this same limit. Now we are lucky here, the function's derivative g prime is already given, so we just need to find f prime of x here, and then we can put in the values. So let's do that. Limit x approaching to infinity. I'm substituting here g prime of x directly, 1 over x plus 4 cos 5 over x. This is the derivative of the denominator. Now let's find the derivative of fx. So f prime of x will be the derivative of 2x, which is 2, the derivative of 3 e to the power negative 5x. So derivative of 3 is a constant, it will be as it is. We just need to do the derivative of e to the power minus 5x. Now this is an exponential function, so its derivative is going to be exactly the same function, but remember there is a negative 5 as the coefficient of x. So when you do the derivative, e to the power negative 5x will be as it is, with a negative 5 coming because of the negative sign here. So this function, now we can substitute. 3 times negative 5 is negative 15 e to the power 5x. So this is what is the final limit that you are getting. Now we have to simplify this limit a little bit, because when we do the limit x approaching to infinity, we need to deduce what is happening here. So I will rewrite this limit in this form: x approaching to x approaching to infinity 2 minus 15 times. Now because this is negative sign, I want to get rid of this. I'm going to put this as e to the power 5x with the positive. So I've put this e to the power negative 5x down in the denominator, 1 by x as it is, and this one is 4 cos 5 over x. Now remember, when your x is approaching to infinity, because you have a lot of terms here which involve x in the denominator, like 1 by x and 5 by x. We can say when x is approaching to infinity, 1 by x will approach to 0. So if it approaches to 0, this limit will after substitution come out to be 0. That's easy. Similarly, 5 over x will also approach to 0. So cos of 5 over x, this term would approach to cos 0. So cos 0 is 1. This is what we'll be needing to simplify. Let's look at the exponential function also. So if e to the power, if x is approaching to infinity, we can say that e to the power x is also approaching to infinity, and therefore 1 over e to the power x, or in particular 1 over e to the power 5x, will approach to 0. So this term will also eventually come out to be 0. So let's simplify using all this information. So I'm going to just put this in brackets. This is what we are going to be now using here to simplify our limit. So we are now doing the substitution. So I will remove this limit now, because we are now substituting the value, or substituting the limit x is infinity. So when I do that, 2 remains unchanged. This is minus 15 times now 1 over 5 e to the power 5x is approaching to 0. So we can say that this whole thing is approaching to 0. So when we multiply 15 with 1 over e to the power 5x, this term is 0, so it is gone. Similarly, this is 1 by x, which is approaching to 0, plus 4 cos 0. Now I can simplify. This is 2, only 2 is left, this is gone, khalas, and this is cos 0, which is 1, so 2 over 4. So I can simplify and get my final answer as 1 by 12. So the answer for the question is going to be E. That's how you solve very, very important question. I hope it is clear and understood by all my viewers. If you've understood the L'Hopital's rule nicely, this is a question I want you to try yourself. Again, a multiple choice question. There are 4 options. Please choose the correct answer. If you want me to check your solution, please put it in the comment section. I will check it for you and give you the correct answer. With that, we have come to the end of today's section. Thank you so much, my dear viewers, for joining. This is Miss Ruchika signing off from today's session. See you in my next video. Bye, students.